Hello and welcome to Excellent Link Academy. For today's class, we're discussing about surd, right? A very important topic in mathematics. For today's class, let's discuss surd and let's look at some basic rule involving surd and how to solve the addition and subtraction of surd. So for this class, we're looking at three things there. Number one, the concept behind surd. Number two, the basic rules of surd. And number three there, the addition and subtraction of surd. In our next class, we'll consider the multiplication and what and division of surd. Alright, let's start with the topic here called surd. Let's call surd by definition. Surd are simply irrational numbers expressed in root form. So I'm saying that surd are irrational numbers expressed in root form. Alright, I haven't understand the definition for surd. Let me show you how surd works. Like if I have root m, or let's say if I have n root p. So this is how you be look. This is how surd appears. So this is how surd appears. So we're having roots of a number, or you have a number and square root of something. So this is how what's it called? Surd appears. All right. Note that when it comes to surd, there are certain numbers that work with surd. If I have, let's say I have root 3, these are what? No, these are numbers we should be expecting in surd. If I have root 5, root 6, and etc. Numbers that when you punch your calculator, if I punch root 3, I'll have my answer in decimal. So it means that any number I press the root and I'm having a decimal number, hence that stuff there is expressed in terms of surd. So note that if I have root 4, we know that root 4 is what? Is 2 already. So this is not what? Not surd. This is not surd. So this is not a surd. So this one is not a surd here. Why? Because I'm having my answer as whole number. So if I'm having root 3, I'll be having my answer in decimal form, which is not whole number, but in terms of decimal. So the idea is that we express surd in terms of what? Let me just say odd numbers if you want to. All right. At this point here, let's discuss some basic rules that guide surd. All right. I've understand this concept here. Let's discuss the basic rules of surd. So let's discuss basic rules of surd. Let's discuss some rules that govern surd. Rule 1 says, let's discuss some basic rule of surd, right? And let's use them to solve some example. Rule 1 says that if I have a square root of a multiplying the square root of a, observe that this and this are the same thing. So when they multiply, what's the concept? I'll be having a square root. This is in a square and a square. So a times a will give a squared. Perhaps a times a. Bring these two together. I'll have something of this nature is now equal to a times a. We are having what there? A squared. In mathematics, square can cancel out square root. So my answer becomes a. So this means that if I'm having a square root of something, multiplying the square root of that same thing, my answer becomes that thing. So it's for me now. Let's take an example to further explain this rule. If I have for this rule here, example to further explain this rule. If I have root 4 multiplying root 4, my answer is what? Is 4. True or false? True. Root a times root a, I'll have a. Root 4 times root 4, I'll have 4. Why is it 4? We said root 4 times root 4 will give root 4 times, so root 4 times 4, abi, what we know, is equal to the square root of 4 times 4 will give 16. So root 16 is what? Is 4, as you can see. That's the idea behind root 1. So root 1 says that if I have the square root of something, multiplying that same thing, I have that thing as my answer. Let me use that to explain this concept here. All right, let's discuss root 2. The second rule that governs surd is that if I have the square root of a multiplying the square root of b, for this case here, they are the same. For this case here, they are different. How do you solve it? My first task now is that I'll have a root. Bring these two together, a times b. That becomes a b. So the second law, or perhaps the second rule that governs surd is that if I'm having the square root of different number multiplying, simply combine them together, as in this case here. That's second rule. So let's take example to explain this rule here. If I have the square root of 3 multiplying the square root of 2, what comes to mind? Square root. Combine the two, I'll have the square root of what? 3 times 2, which will give us the root 6 as my answer. So this is like the application to the second rule of surd. Let's discuss the third rule guiding surd. The third rule says that if I have the square root of a dividing the square root of b, this can be broken down as the square root of a over b. This is other rule that guides surd, that the square root of a number dividing the square root of another number, so can be expressed as this. Pick out this and this, then a big square root. I have this here. Let's take an example to explain this one too. Yeah, example to explain the third rule that guides, or perhaps that governs surd. If I have the square root of 4 divided the square root of what is it? Let's use of 2 of 4. Yeah, we said we can break this down as saying what? The square root of what there? Observe something, please. Square root of what? 2 over 4, right? So, but again, all right, which is 2 divided 4, I'll have 1 over 2. The square root of 1 over 2 as my answer to that question. And also, if I want to, right, if I still want to observe this one here, if I have root 2 over root 4, this is root 2 all over root 4 is what? Is 2, right? So this becomes root what's it called? This becomes root 2 all over 2. These two here, this question can be expressed in two cases here. Either you put them together like this and you have something of this nature, or you do it in this way here, right? So they're still very much correct. All right, I haven't understand this concept behind the basic rules of surd. Let's dive into something very important. Welcome back. Let's dive into something important called basic form of surd. Basic forms of surds. Let's discuss basic forms of surd. All right, when it comes to basic form of surd, here is what you need to note. Write down, or perhaps put down, to express a surd in its basic form, simply divide that surd to its simplest form, or simply break down a surd to its simplest form. That's all. So the idea behind basic form of surd is that the task here is to simplify any given surd into its simplest form, or if you want to break down the surd into its simplest form. Example, let's take example to further explain the concept behind basic form of surd. Example here, find the basic form of the following surd. Find the basic form of the following surd. Number 1, root 50. Number 2, root 12. Number 3 there, root 1100. Number 4, root 27. All right, let's get this done. So we are taught to express this surd here in their basic form. So the question says find this basic form of the following surd. So let's express each surd in their basic form. All right, solution here. I'm having number 1 there is root 50. I'm having root 50. Let's express root 50 in its basic form. Let's simplify it, or let's break it down. What we know is that root 25 times 2 will give 50. True or false? True. We know that 25 times 50. 25 times 2 will give 50. So now the idea is that whenever you are breaking down a surd, or you are taking a surd back to its basic form, the idea is that for that number given, look for a perfect square that can multiply that number to give the surd given. So I'm given 50 here. Look for a perfect square number. So 25 is a perfect square, right? So perfect square are simply number that if when you take the square root, it will give you a whole number as value, non-decimal number. If I take root 25 alone, that will give me 5. So that's what we refer to perfect square. Number that when you take the square root, it will give you the answer in whole number. Example, root 4. 4, perfect square. 16, what is it? 16, perfect square. 144, perfect square. So this is a number like number that I refer to perfect square. So the idea is that I'll separate these two here. I'll be having root 25 times root 2. This is still correct from this idea. I can take this one here back to this, right? So I have this one here. What we know, root 25 is what? We give 5 times this root 2. So it means that I'll be having what? 5 root 2 as my answer. So root 50 in its basic form becomes what? 5 root 2. Let's discuss example 2 here. I have root 12. Let's take root 12 back to its basic form. For root 12, I'll be having what? Root 4 times 3. 4 is a perfect square. So 4 and 3 will give you 12. Separate this one, I'll have root 4 times root 3. Root 4 gives 2 times root 3. This becomes 2 root 3. So my answer becomes 2 root 3 when I take this surd to its basic form. So I have 2 root 3. Let's take C to its basic form, root 1100. From here now, I know that to get 110, if I have root 100 times 11, we give 110. So separate this one, I'll have root 100 times root 11. Root 100 gives 10 times root 11, which will give 10 root 11 as my answer to C. So let's do number 4 there. All right, for number 4, let's take root 27 to its basic form. Let's take root 27 back to its basic form. What do we get? What do we get? All right, I have number 4 there, root 27. What we know is that root 9 times 3 will give 27. True or false? True. From here, I'll have root 9 multiply root 3. What's root 9? That's 3 times root 3. from here I'm having what the 3 root 3 as my answer. We said when it comes to basic form of surd, the idea is that we're breaking down a surd into its simplest form. That's number one. When it comes to basic form of surd, the second thing to note is that always look for a perfect square number, like 9. Look at like 25, like 4, like 100. Look for perfect square number that you can get from that given surd. 27 now. I know very well that 9 times 3 will give 27. So 9 days they were perfect square. So that root 9 becomes 3. So that's like the idea behind basic form of surd. All right. Having understand the idea behind basic form of surd, let's discuss one last key concept before we dive into addition and subtraction of surd. That is called similar surd. When is surd said to be similar? Similar surd. Let's discuss the concept behind similar surd. By definition, surds are said to be similar if they are of the same root, or they are of the same let me use root if you want to, root, right? So when a surd said to be similar, they are said to be similar if they are of the same what, they of the same root or basic form of surd. For instance, from what we discussed here, we said root 50, root 12, root 110, and root 27. Which one here are similar? Look at root 50. This is 5 root 2. This is 2 root 3. This is 10 root 11. This is 3 root 3. So it means that root 12, look up, I have root 12 and root 27. These surd here are similar. Why? Because I'm having the answer, the basic form of 12 gives me 2 root 3, and the basic form of 27 gives me 3 root 3. So this is root 3 root 3. They are similar. So I'm saying that when it's said to be similar, if they are the same root, so root 3, they are similar, irrespective of what is at the front. If I'm having 1 million at the front, does not mean. So if I'm having root 3, they are what? They are similar. That's the concept behind similar surd. All right, let's now use this idea now to dive into the addition and subtraction of surd. How do you add surd? How do you subtract surd? Let's discuss the addition and subtraction of surds. All right, let's discuss the addition and subtraction of surd. So how do you add two surds together? Two or more surd can add or subtract if they are similar surd. So I'm saying that to add or subtract to any surd, observe that or ensure that they are of the same surd, or if you want to, they are similar. So the idea behind addition or subtraction of surd is that they must be of similar surd. So if I have, let's take an example to further explain the concept behind addition and subtraction of surds. If I have root 80 over 1, root 80 times, plus root 15 minus root 18. I have this one here. Number 2 there, I have root 50 plus root 18. Next up, number 3 there, I have root 32 minus root 50. Number 4, I have root 27 minus 5 root 3 plus 2 root 2. Alright, let's get this done. Alright, how do you add and subtract this kind of surd? Note that we said to add or subtract any given surd, the idea is what? Ensure that they are of similar surd. That's the concept. Alright, let's solve number 1 then. Solution. Number 1 here, I'm having root 80 times root 15, plus 15 minus root 18. When it comes to solving problems involving addition and subtraction of surd, your first priority is what? Break down the surd into their simplest form. That is, take each surd to their basic form. So this root 80, take root 80 to their basic form. As I taught you how to take a surd to their basic form. So apply the concept of taking surd to their basic form here. So I'm having root 80. For root 80, how can I get a perfect square from root 80? Right? So what I know is that 40 times 2 will give 80. True or false? True is correct. True or false? True. Plus, this is root 80. I'll break it down a little bit. Plus root 15. What can give root 15? So I know that I know very well that root 15 can also be written as alright, sorry please, sorry. This is not 15, 50. 50, yeah? So I have 50, yeah. Alright, if I'm going root 50, I know that 25 times 2 will give 50. Next up, minus root 18. 9 times 2 will give 18. True or false? True. Alright, proceeding. From here again, I know that this is root 40. This is 40. 20 times 2 will give 40. Right? So times these 2 here, back here again. Observe what I'm doing, please. So plus this can be broken down as what? Root 25 times root 2 for this one here. So minus what there? Root 9 times root 2. From here now, if I break this one down here, this is saying as I can break this down as saying root 20 times root 2 times 2, or perhaps root 2 times root 2. So plus root 25 will give 5, root 2 minus root 9 will give 3, so root 9 will give 3, then my root 2 is here. Alright, I'm taking my what's it called, my time to break this thing down. So what's my next task here? We know very well that if I have root 2 times root 2, we said root 8 times root 8 will give a. It means that root 2 times 2 will give what? 2. So if I want to, I'll put the 2 here first before what the root 20. Next up, plus 5 root 2 minus 3 root 2. At this point here, this is 2. So if I want to break down root 20, I can break root 20 down as saying what there? As saying root 4 times 5 will give 20. So plus 5 root 2 minus 3 root 2. Separate this one here. I'll have that 2 root 4 times, if I want to, I can put times here. So, or better still, I'll have 2 times, this one becomes root 4 times root 5. See the same thing. So plus 5 root 2 minus 3 root 2. At this point here, I'm having 2 times root 4 will give 2. So times root 5. So plus 5 root 2 minus 3 root 2. At this point, 2 times 2 gives 4 root 5. 4 root 5 plus 5 root 2 minus 3 root 2. Also, at this point here, I'm not done yet, but at this point, observe that I have broken everything here into what? Into their what? Basic form. So at this point now, What's your next task? Similar surd, similar surd. These two are similar, so they can what? They can add or subtract. So it means that they are similar. This is root 2, root 2, this is root 5. This is not similar to these ones. So these are similar. So I'll put this one down back. I'll have 4 root 5 plus 5 root 2 minus 3 root 2. The idea is what? Plus 5 minus 3 will give plus 2. Next up, just put your root 2. So this becomes my answer after simplifying number 1 there. So as we have done number 1, let's discuss number 2. Let's get number 2 done. Number 2, then I'm having root 50 plus root 18. How do you add these two surds? What's your task? My task now is break down these two surds into their basic forms, right? So I'll have root 50 first. That's root 25 times 2, as we know, plus root 18 will give 9 times 2, as we said earlier. Yeah, root 50, 18 and 50. From here now, if let's separate this one, I have root 25 times root 2 plus this one here, root 9 times root 2, right? Separate them. At this point here, root 25 will give 5. Then I have root 2 plus root 9 will give 3. Then I have root 2. Observe that these two are similar, so they can they can add. So 5 plus 3 will give 7. Sorry, 8. 8. 5 plus 3 will give 8. Next up I have root 2. This becomes my answer after solving example 2 there. Let's get number 3 done. Let's do number 3. For number 3 there, I'm having root 32 plus, minus 50 please. Minus root 50. Alright, let's get this done. Let's take this one here to its basic form, right? So from here now, I can break root 32 as saying 16 times 2 will give 32, correct? So minus root 25 times 2 will give 50. From here now, I'll be having root 16 times root 2, separating them, minus root 25 times root 2, separating this one too. Root 16 will give 4 with this root 2 here, minus this will give 5 root 2. Can this subtract? Of course, yes, they can subtract. Why? Because they are of similar sort, root 2, root 2. So I have 4 minus 5 will give minus 1. Next up, I have root 2. So I have minus 1 root 2. Or this can be written as or. This is not, if you're writing minus 1 root 2, you're not that mature in mathematics. So the better form of this becomes what then? Minus root 2 as my answer. So it's not going to put 1 here. So minus root 2 is still the best expression for my answer. So you can try to do number 4 and leave your answer in the comment section below. I'll reply you as fast as I can. So next class, we're talking about the multiplication and division of surds, and also how to rationalize surd in different forms. Thank you for watching. See you in our next class.